Now let's look at some relationships inside of circles. Definition number 1. The radius is the distance from the center to the circle itself. If you go all the way across the circle and combine the two radiuses together going through the center, that is known as the diameter. And we can either say that the diameter is 2 radiuses long, or we can say that the radius is 1/2 the length of the diameter. Now, we don't use the word perimeter for a circle, but instead we use the word circumference. And circumference is going to equal diameter times pi. Basically, what we're looking at here is the diameter. Pretend that this was an elastic measure that I could wrap around the circle, and there's one diameter, here's another diameter, there's a third diameter. It goes just a little bit more than 3 diameters. You have pi diameters wrapping around the circle. Some people, instead of using diameter times pi, they replace the diameter with 2r, and they say the circumference is 2 pi r, where the 2 and the r become the diameter. Either one of these formulas is valid for the circumference. Where pi is an irrational number, it's approximately 3.141529, and keep on going and on forever. Most people think of it as 3.14, but it isn't. That's a rounded value, and quite often in our mathematics we like to leave it as the symbol pi and not use the approximation, which gives us inaccuracies. As a historical note, back in ancient Greece, they thought that they could use the fraction 22/7 to represent pi. And it was correct to a few decimal places, but after that it differed from the true value of pi. Now, let's pretend we have this circle that has a radius of 5 centimeters. We could then find that the diameter, which is twice the radius, is 10 centimeters long. If we wanted to find the circumference would be diameter times pi. And if we substitute 10 in for the diameter, we have that the circumference is 10 pi centimeters. Now, usually in our math classes, we just prefer to leave it right there. But sometimes you're asked for an approximation, and we're told to use 3.14 to approximate pi. Well, if that is the case, then the circumference is approximately, notice I'm using a squiggly equal sign, 10 times this 3.14 centimeters, and that is going to give us 31.4 centimeters. Notice how my circumference is measured in regular units. It's the distance around the outside of the circle, kind of like how far an ant would walk if the ant had to walk around the circle. Now, a formula for the area of a circle is area is equal to pi r squared. And so if the radius is 5 in this case, the area would be pi times 5 centimeters squared, which would be 25 pi. We like to put the coefficient, the number, in front of the pi symbol. Now this would be the exact area measured in square centimeters, but if we wanted to find an approximation, we'd actually have to multiply 3.14 times 25, which would be approximately 78.5 square centimeters for the area. You'd actually have to multiply that out by hand or use a calculator. Now I've got an interesting problem for you. I have a figure drawn here. It looks like a dome of a laboratory, so to speak, and we need to find both the perimeter and the area. Now, to find the perimeter, we're going to have 3 linear lengths, 4 plus 8 plus 4. But then after that, we're going to have 1/2 of a circumference being added on. So I'm going to write plus 1/2 circumference, just using a capital C to represent that. Now what are we going to have? 4 plus 8 plus 4 is 16, plus 1/2 of, the formula for a circumference is diameter times pi. So I'm going to write d pi down, and then we'll go from there. Here we go. We've got 16 plus 1/2 times. The diameter of the circle is the same up there as it is down below, which is 8 times pi. So 1/2 times 8, that will cancel to give us a 1, and we would have 16 plus 4 pi centimeters. Now that would be an exact answer, and I would put parentheses around that because it's 16 centimeters plus 4 pi centimeters. Or we could substitute in for pi 3.14 to get an approximation. And so 3.14 times 4 is going to give us 12.56. So I'd have approximately 16 plus 12.56 centimeters, which is approximately 28.56 centimeters for the distance around this figure, for the perimeter. Now let's find the area of this picture. Now the area is going to be a rectangle at the bottom plus half of a circle for the dome at the top. Now the area of a rectangle is length times width, so we're just going to have 4 times 8 for the area of the rectangle, plus 1/2 of the area of a circle, which is pi r squared. So the area of the rectangle, 4 times 8, is going to be 32 square centimeters, plus 1/2 pi times r squared. Well, if it's 8 units all the way across, I can split that up, put my center right there, and know I've got a radius of 4 centimeters. So I'm going to have 4 squared. So this is 32 plus 1/2 times 16 pi. 1/2 times 16 is going to give us 8. So we have 32 plus 8 pi. Now that 8 pi, if we need an approximation, 3.14 times 8. 32, carry our 3, 8 times 1 is 8, plus the 3 is 11, carry the 1, 24 plus 1 is 25. So 25.12. So we've got approximately equal to 32 plus 25.12, which is approximately 57.12 square centimeters, because area is measured in square units.